Okay, in this video, I want to take another example of block diagram reduction. But in this case, instead of following the signals all around, what we'll do is we'll try to combine the blocks in the block diagram so that in the end, we are left with only one block. Okay, so as we'll proceed, you will see how we go about it. Now, without a doubt, the examples that I'm taking are much more complicated than the examples that you would be dealing with especially as a part of this module. But I just want to show you the more complicated examples, and my guess is the easier ones would be much easier for you. Okay, so let's take a look at this block diagram. So we have a block diagram here as is shown here in the top slide. And instead of starting from the left and writing the signals all along the block diagram, let's use another method to figure out the output of the block diagram. Okay, and the first step what we'll do is we can see that there is a pick-off point at this point, right? So we'll try to move this pick-off point after G4. One of the reasons why you would do that is if you move the pick-off point after G4, as you see here, then this feedback loop is a single feedback loop. And it's fairly straightforward to reduce this feedback loop into one block. If you can do that, then this block, and this one make another feedback loop, and that can be reduced into one block. And that, along with this feedback and G1, would make another block that could be reduced again. Okay, so we want to take the pick-off point from here and put it here. So what would happen to H2 if you do that? You will have to divide it by G4, right? Whatever signal is here is being fed back is going to be multiplied by H2. But if you put this pick-off point here, the same signal is being multiplied by G4. So we want to kind of divide that signal. So you go here. One of the ways in which you realize that you want to do this is by looking at the transformations that I showed you in one of the previous videos. And there's a list of transformations, and one of the transformations, this transformation is also there when you want to move a pick-off point after a gain. Okay, so once we move the pick-off point here, this gain at the feedback becomes H2 over G4. Okay, now what we want to do is we want to combine this feedback loop and make it just one block. Okay, so that's what we are doing here. So we want to combine this and make it into one block. And again, if you go back to your block diagram transformations chart, you will see that this is simply going to be G3 times G4 divided by 1 minus G3 G4 H1. So that's what they've got. Now you want to combine this loop and make it into one block, and that's going to be G2 times this thing divided by 1 plus G2 this and this. Okay, so that's what we've got here. So if you reduce that, you get this block diagram, and again this is a simple feedback loop, and the output is going to be this G1 times this transfer function divided by 1 minus G1 times this times H3. And if you reduce that, you would get this block diagram. So either of these ways, one which I showed in the previous video or this one, both works to get the transfer function of the system. And whichever method you prefer, you can do that. My guess is you will have to try this method out in a few problems and see which one you prefer. I'll put out a sheet with different block diagrams for you to work out and get the output of.